using a Venn diagram with conditional probability. So we're going to go through just the referring to what the Venn diagram notations are. This notation is A and B, the intersection. So that's this piece right in here. It's the overlap. The notation here, A union B, refers to the word or both. So it's both of these pieces. And then the last one, mutually exclusive, means that there's nothing in common with either one. There's no overlap, so nothing in A and nothing in B overlap. So the conditional probability formula, how you say this is the probability of A given B. So this notation here, this little line says given. So it's the probability of A given B is how you say that. So the formula we use is we take the intersection, probability of A intersecting B, so that's going to be in the numerator of your probability, and then the probability of B is the entire circle, and you would divide those. All right, so here's our example. So we have 25 students in our class. So this Venn diagram total represents 25 students. And we have two events, people who like pizza and people who like iced coffee. So I'm going to say up here, these are our students who like pizza, and these are our students who like coffee. One student likes neither. So they're out here, and there are 6 that like both. So they're my intersection. Now we need to figure out what's going to go into the other 2 places. So they say 14 like pizza. So if we have 6, and there are a total of 14 in that circle, 14 minus 6, we have 8 over here. Then 16 like iced coffee. If they have 6 in here, there's 10 left. So now we've set up our Venn diagram. Now we're going to go ahead and answer a couple questions below. The first one is, what's the probability that if you choose a student at random that they like pizza? So we're going to total up the amount of students who like pizza, 8 and 16. There are 14 students total. So now what is the probability they like pizza? So there are 14 students that like pizza out of the entire class, 25. So you have a 14 out of 25 chance that like pizza. All right, question 2. What's the probability they like pizza given that he or she likes iced coffee? So they like iced coffee, and we want to find out what's the probability they also like pizza. So the probability is going to be they like pizza given that they like iced coffee. So shorten it up, probability of pizza given they like coffee. So we're going to go ahead and set up our formula. So remember, the numerator is the intersection of those who like pizza and coffee over your probability of B. Well, in this case, it's the probability of C. Probability of those who like coffee. All right, so we head up. How many students like both? So here's your intersection. So the probability of A, probably shouldn't use A, I'm so used to using A. Probability of pizza and coffee. There are 6 out of 25 students. Then we have to find the probability of our coffee. How many students like coffee? There are a total of 16 out of 25. I will head down. So the intersection, was 6 out of 25 students. And then the students who like coffee, 16 out of 25. Fraction divided by fraction, so we're going to keep the first fraction, change it to multiplication, and 25 over 6. Cancel, 16. Cancel our 25s. 6 out of 16 can reduce by half. So you have 3 out of 8 chance to pick someone. They like coffee, given that he or she also likes coffee.